projects. In this video, we are going to explain about a project titled A Data Analytic Approach to the Cybercrime Underground Economy. The project explores the increasing danger posed by the cyber attacks and cyber crimes, causing the individuals, organizations, and governments to face difficulties in protecting themselves. It emphasized the consequences of cybercrime by the widespread impact of WannaCry attack in 2017, affecting nearly 100 countries. Furthermore, the project acknowledges that organized criminal organizations are responsible for numerous recent cyber attacks, prompting the governments to allocate the more resources to their cybersecurity budgets in order to counter this menace. The objective of this project is to examine the underground economy of cybercrime through the introduction of a data analysis framework. It involves defining a concept such as crime as a service and crime away, proposing a classification model related to these concepts and creating a practical amplification to showcase the implementation of the suggested framework and classification model. The project's objective is to contribute to the development and design artifact, foundation, and methodologies in this field, while offering valuable insights to the practitioners. It also provides the guidelines for governments and organizations across the various industries to better prepare for cyber attacks originating from the cybercrime underground. The basic requirements that are needed to build this project are operating system of Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirement Python IDE with version of 3.7. These are the modules that are implemented to build this project. First module is dataset upload and analysis. In this module, the first step is to upload the dataset containing the information about the cybercrime incidents. The dataset could include the various attributes such as the type of cybercrime, date, time, location, and other relevant information. After uploading the dataset, the module performs analysis method to gain insights into the data and counting the occurrence of different types of cybercrimes. This involves identifying the different categories of cybercrime present in the data and calculating the frequency or count of each category, and cleaning the dataset by removing the missing values and affecting the accuracy of the analysis and modeling. And the second module is dataset processing and analytic methods. In this module, the dataset is further processed to prepare it for training a classification algorithm. Here, encoding a tag label with integer. Since machine learning algorithms typically work with numerical data, categorical variables like type of cybercrime need to be encoded. Each unique category is assigned a unique integer ID. This conversion allows the algorithm to work with the encoded labels. And by splitting the data into the training and testing part, here the application constitutes 80% of data set for training and 20% of data set for testing. And the third module is run naive-Bayes classification model. In this model, the naive-Bayes algorithm is applied to the training set to build a prediction model. Naive-Bayes is a popular classification algorithm that utilizes the Bayesian probability theorem to predict the probability of a given sample belonging to a particular class. The algorithm learns from the labeled training data and builds a model based on the assumption of independence between the features. And the fourth module is classification performance graph. This module focuses on evaluating the performance of the naive-Bayes classification model. The accuracy and the precision of the model are calculated using the test set. Accuracy represents the overall correctness of the model prediction, while the precision measures the model ability to correctly identify the positive instance from the total predicted positive instances. The model plots a graph to visualize the accuracy and precision of naive-Bayes model, allowing for the better understanding of its performance. And the final module is predict the cybercrime. In this final module, the trained naive-Bayes classification model is used to predict whether the test cybercrime network dataset contains any cybercrime signature. The test dataset, which is not used during the model training, is uploaded, and the classification model predicts whether each instance in the test dataset represents a cybercrime or not. The prediction provides insight into the presence or absence of cybercrime signature in the test data. Overall, these modules provides a comprehensive pipeline for analyzing, processing, modeling and predicting the cybercrime incidents using a naive-based classification algorithm. For the execution of the project, execute the project, first we need to open the code folder. This is the code folder consisting of different files. The first one is dataset folder. It consisting of malware and test data sheets. Here when you click on malware sheet, here it consisting of different columns and rows. In the same way for the test data, consisting of different rows and columns. And this folder is model. You will have the .hy files within it, which contain the learning algorithm information which can be loaded into the project code during the runtime to utilize the trained model for various tasks such as making predictions on new data or performing the specific operations. And the main one is an Python file consisting of the main code file, and this one is a run.bat file. Is used instead of executing the program in command line interface. We created the Windows bat file to execute the project. Now to run the project, double click on run.bat file. This is the graphical user interface. With this we are interacting with the program. And now click on dataset upload and analysis. Using this button, we are going to import the dataset from this folder. Here we are selecting the malware.csv file and click on open button. Here we can see that the dataset is loaded. And dataset contains some of numeric and non-numeric characters, and the algorithm will not take such non-numeric data. So we need to convert it into the integer ID, and in the above this we can see the various cybercrime and its count. So by seeing this we can analyze on which cybercrime most money is using, and we can analyze it by this graph and close this graph. And now click on dataset processing and analytic methods. In this screen we can see all the data is converted to the numeric format, and then we can see total dataset is to be divided into the training and testing part. Here we are taking off 80% of data for training and 20% of data for testing. In this way the dataset is ready, and then click on run naive-based classification model. Here, the naive-based classification model is generated with an accuracy of 90.8, precision of 92.2, recall of 90.8, F-score of 90.9. And then click on classification performance graph button to get this graph. And this graph x-axis represents the algorithm which we used, that is naive-based, and the different color bar represents the different metrics such as accuracy, precision, F-score and recall. Here blue bar represents the accuracy, orange bar represents the F1 score, green bar represents the precision, and red bar represents the recall. And then close this graph and click on predict the cybercrime button. Here by selecting the test data and clicking on open button. Here the square bracket we can see the network traffic, and after the arrow button we can see the type of cybercrime attack prediction. As in this, for this data it is predicted as brute force excesses, and for another data it predicted as Bengay. And this way we can predict the cybercrime attack by using the naive-based classification model. The project concluded that the proposed data analysis framework and the crime-wave definitions and associated classification model can be used to investigate the cybercrime underground economy. The example application developed in the project demonstrate how the proposed framework and classification model could be implemented in practice, and it suggests the guideline for government and organizations in all industries to prepare for attacks by the cybercrime underground.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.